would now like to talk about another way that you can explain this idea of simplifying fractions. Let x be equal to 12/20ths. If we multiply 20 to both sides, we get 20x is equal to 12. I plan to explain in a future set of videos why you can do the same thing to both sides of an equation, and when I create that future set of videos, I plan to link in the description of this video. But anyway, we can divide 4 on both sides, and we get 5x is equal to 3. We can divide 5 on both sides, and we get x is equal to 3/5. Because x is equal to x, we can now know that 12/20ths is equal to 3/5. Let's now use the same pattern in the previous slide, but let's now use more variables to explain this idea of simplifying fractions in a general case. Let x be equal to AC over BC, where A is any real number, B is any real number but 0, and C is any real number but 0. I can multiply both sides by BC. Now I can divide both sides by C, and I get bx is equal to a. I can divide both sides by b, and I get x is equal to a over b. Because x is equal to x, AC over BC is equal to a over b. Here is 2 slides that explain that the method we used in the previous 2 slides for explaining the why behind for simplifying fractions could also explain the why behind for expanding fractions by going in the exact opposite way. Here is a slide with just one variable and with several more variables. I would now like to explain in yet another way why this idea of simplifying fractions works. Let's talk about 12/20ths. 12/20ths times 1 is equal to 12/20ths because anything times 1 is equal to that anything. Likewise, anything divided by that anything is equal to 1, so 1/4 divided by 1/4 is equal to 1. Now let's rewrite the divide sign as so, and now we're multiplying 2 fractions. I plan to explain in a future set of videos why you multiply fractions in this way of multiplying the numerators and multiplying the denominators, and when I create a future set of videos, I plan to link description of this video. But anyway, we multiply the numerators and multiply the denominators to multiply these 2 fractions together. Now 12 times 1/4 is equal to 12/4, and 20 times 1/4 is equal to 20/4. Now 12/4, that is 12 divided by 4, and 20/4, that is 20 divided by 4. 12 divided by 4, that is 3, and 20 divided by 4, that is 5, and so we end up with 3/5. Therefore, 12/20ths is equal to 3/5. So this is yet another way to explain why this idea of simplifying fractions works. Ultimately, what we did is that we divided both the numerators and the denominators by 4. Let's now use the same pattern in the previous slide, but let's now use variables to explain the why behind for simplifying fractions in a general sense. Let's talk about AC over BC. Now anything times 1 is equal to that anything, so AC over BC times 1 is equal to AC over BC. Now anything divided by that anything is equal to 1, so 1 over C divided by 1 over C is equal to 1. Now let's rewrite this divide sign as so. Now we're multiplying 2 fractions, so must multiply both the numerators and denominators. Let's rewrite the AC times 1 over C as AC over C, and let's rewrite the BC times 1 over C as BC over C. And now let's rewrite these divide signs, and let's simplify this. AC divided by C is equal to A, and BC divided by C is equal to B, and so we're left with A over B, and therefore AC divided by BC is equal to A over B. Now let's use the same idea, but let's now talk about it to explain the why behind for expanding fractions, and let's not introduce variables quite yet. Let's talk about 3/5. Now anything times 1 is equal to that anything, so 3/5 times 1 is equal to 3/5. Now anything divided by that anything is equal to 1, so 4 divided by 4 is equal to 1. Now let's rewrite this divide sign as so, and now let's multiply these fractions by multiplying both the numerators and the denominators. Now 3 times 4 is equal to 12, and 5 times 4 is equal to 20, and so we're left with 12/20ths, and we find out that 3/5 is equal to 12/20ths. Let's now use the same method as we just did, but let's now use variables to talk about this idea of expanding fractions in a general sense. Let's talk about a over b. Now anything times 1 is equal to the anything, so a over b times 1 is equal to a over b. Now anything divided by that anything, as long as that anything is not 0, because we cannot divide by 0. But anyway, anything but 0 divided by that anything but 0 is equal to 1, so we can rewrite that 1 as c divided by c, because in this case c is not 0. Now we rewrite the divide sign as so, and now we're multiplying two fractions, so we multiply both the numerators and the denominators. Normally when we have a times c, we write it as ac, and normally when we have b times c, we write it as bc, and so this is ac over bc. And so we find out that a over b is equal to ac over bc. Let's now talk about yet another way to explain this idea of simplifying fractions. Let's talk about 12/20ths. Now 12 is equal to 12 times 1, and 20 is equal to 4 times 5. And so we get this, 12 times 1 over 4 times 5. Now because multiplying fractions means multiply both the numerators and denominators, this is equal to 12/4 times 1/5. Now we can rewrite the divide sign of 12/4 as so. Now 12 divided by 4 is equal to 3. Now 3 times 1/5 is equal to 3/5, and so we find out that 12/20ths is equal to 3/5. Let's now use the same method that we just did, but let's now use variables to explain this idea about simplifying fractions in a general sense. Let's talk about ac over bc. Now, because of the commutative property multiplication, which I explained in a previous set of videos, the link for that set of videos should be in the description of this video. But anyway, because of the commutative property multiplication, BC is equal to CB. B times C is equal to C times B. Now, AC is equal to AC times 1, and CB is equal to C times B. And so we can rewrite this as AC times 1 over C times B. Now, this is equal to AC over C times 1 over b, because to multiply fractions, you multiply both the numerators and denominators. So we're kind of undoing that multiplying. Now AC over c is equal to AC divided by c, and AC divided by c is equal to a, and a times 1 over b is equal to a over b. And so we find out that AC over BC is equal to A over B. We can use the same idea the same way to talk about the why behind for expanding fractions and not just for simplifying fractions. However, we're basically doing the exact opposite. We're going the exact opposite way. So I'm just going through a few slides about this rather than going in detail. Thank you for watching this video. Here is a link to the playlist about simplifying and expanding fractions, in which this video is a part of. Feel free to click on this link.